To begin the process of reducing two equations, we first need to enter the bottom equation into the machine. To do this, we'll be using our decimal card input, and we'll type in a 1 followed by an x to create the 1x, a 0, 3x to create the minus 3y, and then a 0, 1, 1x to create the minus 11. This is a representation of the punch card on our tablet here, and we'll go ahead and hit upload to upload into the machine. So once we see it is connected and successfully uploaded, we know that we have entered that data. So that data is currently being held by this ESP module, but it will not output anything until this wire is pulled high. Before that, we need to clear the drums. So we'll take our reset CA and reset KA flags, pull them both high, and we will step through a full cycle of the drum, just to make sure that all data is erased from them. Then we pull them low, and we can pull this high to enable the ESP module. And now we need to step through cycles until this decade counter resets to 15. Now that the decade counter has set to 15, this ESP module will begin outputting data corresponding to each decade on the decade counter. For our example here, we only have data starting at the lowest two decades, so we're going to get zeros for most of it. But you can see the leading 0 to create the negative numbers already changes the sign bits of y and z here, which are being reflected in our add subtract modules there and there. So now, continuing on, we're going to wait until this gets to about the second decade, and then we'll go through the rest of it slower. Okay, let me finish out this cycle here. Now that we're at this first decade, we're going to get the 10 part of the 11 loaded into the machine. So we have this bit here of z asserted because it's a 1. And that is going to combine with this decade and this address from our timing drum as an address into these EPROMs, so that this EPROM specifically will output a binary representation of 10. Then that binary representation of 10 will be subtracted from 0, since we're subtracting, and that'll give us a value of negative 10 stored on the drum. So we see at address 0, we have nothing because the first bit of 10 is 0. Then the next one is 1. So let me make sure we have our select lines enabled so that we see that 1 reflected in the adders there. 0, and then the 1 again. Now, since this is a negative number stored in 2's complement, the resulting additions will have a borrow bit that will make all the rest of the bits in the number 1. Then we have now moved on to decade 0, so we can see that the x here is outputting a 1, since we have 1 loaded in, 3 for 3, and a 1 for that last one here to make 11. So stepping through in the same manner, we get that 1, 1, 1 there, and we'll perform the additions or subtractions from here on out. Okay. With that done, we're going to go ahead and disable this ESP module, change this to its idle position so that we're not doing any operations with the data on the drum. And we're going to go ahead and write that out as a binary card over here to make sure that it's stored in properly. So by stepping through the cycle, we can see this data has been written to this binary card here, transferred here, and if we hit the proper mode, we'll see that we have stored a 1, minus 3, and 11. The next step after loading in the first equation is to transfer it from the CA drum to the KA drum. To do this, we'll go ahead and insert this transfer flag, which is denoted by this LED here. Step through a full cycle, and then disable the transfer. Now that that data is loaded into KA, we'll go ahead and clear the data from CA by toggling only this black or gray flag here to represent the KA. To prove that this data is now contained on KA instead of CA, we're going to step through and we should see these LEDs populating, but nothing over here. With that data looking good, we're going to go ahead and move on to uploading our second equation for our system. To do that, we are going to clear our entries here, and then we're going to type in 2x, 4x, and 8x to get 2, 4, 8. With another click of the upload and an enabling of the ESP module, we can go ahead and step on through our decades until it resets to that 15. With this reaching 15 now, we're again reading this data, but because we have nothing for these higher decades, we gotta wait to see any of these LEDs flash until the very last one. We'll finish this cycle out. So now that our decade is 0, we have this bit asserted to represent a binary 2, this bit 4, and this bit for 8. So that is going to combine with our decade here and our timing address here to create the address for these EPROMs, so that we should see the 2, 4, and 8 loaded onto our drum. So at address 0, none of those are asserted, but then at the next address, we have a bit asserted here for 2, then 4, and then 8. Finishing out the cycle now, we'll go ahead and disable the ESP module, disable any operations, and we will write out that to binary. So with that second equation now loaded into CA, we're going to verify that it's in there by enabling this ESP module and stepping through a cycle. Here we see that the binary 2, 4, and 8 were written, and this page transferred onto our reader. Now we will actually do a calculation of the two equations. So how this will work is the modified Gaussian algorithm requires us to subtract that first equation that we entered from the second equation enough times in order to zero out a coefficient. So for the purposes of this demonstration, we're going to start by zeroing out the x coefficient first, which means we need to take that first equation and subtract it twice from the second equation, or the first equation subtracted twice from the second equation. So to do that, we'll set this into subtract mode. So all these LEDs are populated, and we're going to set these select lines to both be high to make sure that the second input into these ASMs is that KA drum. Stepping through the first of these subtractions, we eventually get to a stable point where we can iterate on through the rest of them, and then we need to do that one more time. With those two subtractions now taking place, we should have a 0 on the X column, or this part of the drum, but we could verify that with a simple binary card readout. Looking at the binary card as it transfers to the reader, we can see that we in fact successfully zeroed out the x's for this equation, so now we're just left with 10y is equal to 30. Now that we know that y is equal to 3, we could start by inputting that equation into our machine and then reduce it with the other equation to solve for x. So I'm going to start by clearing this out, and then we're going to enter 0x, 1y, and 3z. Hitting upload on here will send it to the ESP module, but before we enable that, we're going to go ahead and reset both of our drums. With these drums now reset, we're going to go ahead and enable the ESP module, and again step through the decade cycles until we reach 1 again. Now we can verify that we have that data loaded in by just stepping through some clock cycles. We should see that at address 0, we have 1 bit lit up on both the second and third columns. Then at address 1, we have only 1 bit loaded on the third column because this one is storing the 1 and this one is storing the 3. Finishing the cycle out, our next step is to transfer from CA to KA, like so, and reset CA. Okay, we can quickly verify that the data is now loaded into KA by watching these LEDs flash on each write cycle, and we know we're good to go. So at this point, we have a couple options. We could enter that 2x plus 4y equation into the base 10 reader here, but since we already have it loaded as a binary card here, we can demonstrate our binary read in. So this card has 2, 4, 8 loaded into here. And by hitting upload, we're going to connect to the ESP module and upload it to this one specifically. Pulling the enable high for it, while also setting our input to be from that device. We can step through and see that at address 0, we have nothing because none of the numbers have the first bit asserted. But then the second one has this bit asserted for 2, then 4, and then 8. We'll go ahead and disable the module after stepping through the full cycle, reset the inputs, and now we're ready to do our subtractions. So for this reduction, we have 4y loaded in CA, 1y loaded into KA. So all we need to do is just subtract KA from CA 4 times to reduce that y to 0. So I'll start by setting this into subtract mode, connecting the 2 drums together like so, and we will complete our first subtraction, second subtraction, third subtraction, and our final 4th subtraction. Okay. Resetting these control signals back down to their original values and enabling our binary card writer, we can visualize the output on the drum. Looking at the newest page created on our reader tab, we can see that we now are left with the equation 2x is equal to minus 4, which means that x is equal to minus 2. And thus, we have completed our solving of a 2-equation system of linear equations using the ABCm.